Hey guys, Mr. Cruz here, and for the second half of this week, we need to talk about how we name different compounds. Oh yeah, I've been doing that a lot already. I named this one Sarah, and this guy's Michael. This one is named Titania, and this is Jeff. Okay, I like the enthusiasm, but nah, we're not gonna do that kind of naming. Uh, Chemists, we have this very specific, systematic way that we name things that we call the IUPAC formula. We do it so that no matter who you are, where you are, what language you speak, it's easy to tell you exactly what compound you're working with. We also have it set up this way so that if we find any new compounds, we'll know immediately what we should name them based on this system that we have for naming. So I'm going to jump right into it and show you how to take a name of a compound and find the formula. Then we'll talk about how you can take the formula and figure out the name, which is a tiny bit trickier. Okay, so let's get started. We're going to start with finding the formula from the names. So the formula is that little shorthand with the chemical symbol and the letters. We're going to start there, and then we're going to move to finding the name from the formula. To begin with, though, for ionic compounds, we've got this super helpful thing called the crossover rule. It's for ionic compounds only, and it states that if we can find the charge of an ion in a compound, it'll tell us how many of the other ion we've got. Let me give you an example. So let's take calcium nitride. We know we've got calcium, and we know we've got nitrogen. We want to find the formula for this. So to do that, we just need to find the charge of each of these. For calcium, the charge is +2, and for nitrogen, the charge is 3-. What we're going to do is we're going to take this little tube right here, and we're going to bring it down and put it at the bottom of the N. And then we're going to take this 3, and we're going to bring it down and bring it to the bottom of the calcium, the Ca. Now notice the charges, the plus and minus didn't come with it, just the number did. When we put all that together, what we get is Ca3N2. This is the formula of calcium nitride. So then the question becomes, how do we quickly find the charge? Because I don't want to have to literally draw out the Lewis dot diagram of every one of these and figure out, okay, well, calcium lost 2 electrons, so it has a +2 charge, and nitrogen got 3, so it's a -3 charge. I don't want to do that. I don't want to mess with all that. I want something quick and dirty that I can use to just figure out, all right, the charge of this is going to be +1, +2, +3, -4, something like that. I need something quick, and where that comes in is on the periodic table, all right? Very quickly, we can tell what the charge of an ion is based on its position on the table. Think about it. If you have a group 1 element, it has 1 valence electron to give. When it gives it up, it has a +1 charge. For everything in group 2, they're going to wind up with a +2 charge. Everything in group 3, they're going to have a +3 charge. Group 14 gets a little weird because it can add or subtract, so it can have a +4 charge or a -4 charge. We usually don't deal with those in this class. That's more of a chemistry thing. For our group 15, now we're getting into territory where they gain electrons. So they'll have a -3 charge. Everything in 16 will have a -2 charge, and everything in 17 will have a -1 charge. What I would do is I would sketch out the periodic table, and I would write these little charges above each of them and use it as a reference while you work through problems, until you do it enough to just memorize it, right? But if you know this, it makes it so much easier to find formulas from names, because you can just look at what elements you've got, figure out what charges they would have, and then cross them over, just like we did before. So then we have to ask, well, if I've got the name of something covalent, how do I find the formula for that? How do we find the formulas for covalent stuff? Well, the name will tell you what to do. And that'll be more obvious when we look at how we name things, which we're going to do in just a minute. So I'm going to circle back to that in just a moment. Stick with me. Now we need to talk about finding names from formulas. We looked at how to find formulas from names. Now we're going to flip it around. Names from formulas. And to do that, we're going to have to go to a flowchart. All right, so we're going to build a flowchart for naming compounds that, if followed correctly, will always give you the correct name. As long as you follow this, you should be in the clear. So where does it start? Well, to start, we name ionic and covalent stuff differently. So the first question we need to ask is the first element a metal? Because if it is, it's ionic. If it's not, it's covalent. So if the first element is a metal, so that'd be yes to that question, then we're going to write the name of both elements. Then we're going to add "ide" to the ending of the second element. And then we're done. That's all you have to do for a compound that has a metal in it. Now let's look at what happens if we don't have a metal. We're still going to write the name of both elements. We're still going to add "ide" to the end of the second element. But then we're going to add prefixes from the chart below. So this is the prefix chart. That's right, there's a chart within this chart. And it's going to tell you, based on how many elements are in the formula for a compound, what prefix you should put before the name of it. So if I use my fingers here to count, the prefixes should be for 1, mono, 2, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And deca. But there is one exception to these. Don't use mono for the first element. If there's only one at the first element, you wouldn't use that. Let me show you an example. This is methane, but it has a more science-y name that we're going to try to figure out today. So to start with, if I think about my flowchart and I begin at the start of it, it asks me, is there a metal? Well, in this case, no. Carbon isn't a metal, and hydrogen isn't a metal. So the next thing that I'm going to do is I'm going to write out the name of both of these. That's the next step in the flowchart. Carbon and hydrogen. Then I add "ide" to the end of the second element. So that's carbon hydride. Then I add my prefix. So there's 4 hydrogens, so that'll be carbon tetrahydride. There we go. Tetra for 4. Do I need to add mono to the carbon? No, because remember, you don't add it to the first element in a compound. Okay, so now let's try this with a different one. I have sodium and oxygen, Na2O, and I have to figure out the name of this. So to start with, what I'm going to do is I'm going to ask that first question that I always ask. Is the first element a metal? Well, in this case, sodium is a metal. So the next step is I write the name of both elements, sodium and oxygen. And then I write "ide" at the name of the second element, sodium oxide. And I'm done. That's it. This is sodium oxide. I don't have to do that prefix stuff because my flowchart told me if there was a metal, I don't have to do that. All right, let's try another one of these. So I'm going to start where I always start. Is there a metal as the first element? No, hydrogen isn't a metal. So I'm going to follow that line on the flowchart. The next question, or the next thing that I always do is I write the names of both of the elements, hydrogen and sulfur. Okay, don't mind if they're a little wonky, that's just PowerPoint doing its thing. So I write both of them out, and just like I always do, I write "ide" at the end of the second element. So I have hydrogen sulfide. But I'm not done, because my flowchart says now I have to add prefixes. So I have 2 hydrogens, which means that this goes from hydrogen to dihydrogen. And then I have 1 sulfur, so that's going to become monosulfide. That means that the name of this is dihydrogen monosulfide. There we go. All right, let's do this example. We've got potassium and chlorine. So, the first question, do I have a metal? Well, yeah, potassium is a metal. So I know that I'm going to write out the name of both of the elements. That's the first thing on my flowchart. Then the next thing that I do is I take the second element and put "ide" at the end, potassium chloride. So remember how I said that I would come back to finding the formula from the name for covalent? Let's look at one of those right now. Here I've got something called dicarbon hexahydride, and I figure out what the formula for that is. Well, I'm going to break it down into the 2 different words. Dicarbon. I know that the prefix di means 2, so that means I've got 2 carbons. C2. And then when it comes to hexahydride, hexa means 6, hydride means I've got hydrogen. H6. So my formula would be C2H6. It's pretty straightforward. So what I'd like you to do now, in lieu of an actual Google form, is I'd like you to just draw out the flowchart yourself. Rewind the video to where the flowchart is and copy it down so that you have one on paper. Likewise, go back and sketch out the periodic table and write the charges at the top, like I told you to do in the middle of this video. Do that and post it on this assignment in Google Classroom, and that can count instead of a Google form this week. So yeah, that's naming. It's not the most exciting thing in chemistry, but it is super important in helping us communicate with one another. Remember to like and subscribe, and thank today's sponsor, Taputi. Taputi is noted as being the very first chemist. She was a 1200 BC Babylonian woman who made perfumes for the royalty in the local area. She recorded her process of distillation on the cuneiform tablet that you see before you. This is our oldest known lab notebook, you guys. They really did write it on stone tablets back in the day. She is one of my favorite chemists. She's an absolutely amazing woman, and without her, chemistry never would have taken off when it did. All right, thank you very much, everybody. Have an awesome day.